We're going to be on page number 49 today. Page number 49. All right. Exponents. Exponents. Okay, now. Okay. This number right here is called a base. This right here is called an exponent. Okay? So, we have a base and we have an exponent. The base can be a number, or as we get into algebra and other parts of math, it could be a letter. Okay? We're not going to worry about that right now. What we're worried about is that this is a number. This is a base. Okay? This number right here is called an exponent. What this means is that it is going to be the base times itself. Okay? 3 times 3. Okay? So we have a 2 up here. We use 3 2 times. If we had a 4, we would use 3 4 times. Okay? 1, 2, 3, 4. So we do 3 times 3 is 9, times 3 is 27, times 3 is 27 times 3, 81. 81. Okay? So, the exponent tells you how many times you multiply the number times itself. The base is the number that you multiply. All right? Now, yes. Yes. Okay? So, what we use exponents for is to make things smaller. For instance, when we're doing division of prime, we talked about that last week. We did some of that last week. If we have the number 16, and we're dividing 16 up into prime numbers. Okay? What's a prime number that goes into 16?
3.
What? 2. 16 divided by 2 is?
8.
What's the prime number that goes in 8?
2.
2. 8 divided by 2 is?
4.
What's the prime number that goes into 4? 2. What do we get?
2.
Okay. Is 2 a prime number?
Yes.
All right. That means we stop right there. So what we would have is we have 2 times 2 times 2 times 2 equals 16. Okay? Or I can have 2 to the 4th power equals 16. Which would you rather write? This really long ugly thing or this right here?
The ugly thing.
The really short one. And yes, you would rather write the really short one too because this takes up less time. I know you want to take up less time than doing your math. You want to get your math done as much as you can. As fast as you can. Yeah. So that's why I'm showing you the shortcut.
But I don't understand it.
That's why we're talking about it today.
Can you review it again?
We'll go over it a lot more.
Okay. Thank you.
Okay? Let's look at the number 72. 72. We're going to do division of primes, and we're going to do 72. What's a prime number that goes in 72? What? 2. Okay. 72 divided by 2 is going to be?
31.
It's going to be 36. 2 goes into 7 2 times. Okay. Sorry, 3 times. So we get a 3. We get 7 minus 6 is 1, gives 12. So 36, okay? So, prime number that goes into 36. 2. What do we get? 18. Good job. Okay, prime number that goes into 18. 2.
9.
We get 9.
3.
3.
3.
What's the bottom down here?
3.
3.
Prime number?
Okay, it's 3 prime number.
Yes.
So we stop right there. We get everything all the way down to prime numbers.
Oh, I know what is it.
So I can write this as 2 times 2 times 2 times 3 equals 72. Or I can write it as 2 to the third power times 3 to the squared. Okay. I use a 3 because I have 3 2's. Okay. And 2 is my base. I have a 2 right here because I only have 2 3's, and a 3 is my base. Okay?
Okay.
Make sense? Yes.
I don't really get it. Me neither.
Okay. So what part don't you understand?
Like the weird tiny numbers.
The weird tiny numbers? This weird tiny number right here is a 3. That says this right here is the same thing as this right here. Okay? This is just saying that I have 2, and I'm multiplying it 2 times 2 times 2 3 times. Okay? Yes.
If you have like common numbers, so it's like 2, 2, and 2. But what about if you use the 3?
Then I have the 3's right here. I have 2 of them, so I have the 3 and the 2 right here.
Oh. So
Okay.
how do you times it?
What do you mean?
How do you times it?
How do I multiply it?
Yeah.
It'd be 3 times 3. And then I have a multiplication sign right here. So I have
So it's like
3 or 2 to the third power times 3 squared. So if I multiply 2 times 2 times 2, that's going to be 8. I have 3 times 3, that's going to be 9. So 8 times 3 is, 8 times 9 is 72. Okay? Yes?
How come the 3 times 3 is 3 squared and not 3 to the power of 2?
Because 3 squared is easier to say. Whenever you have a 2 right here, it's called squared. Whenever you have a 3, it's called cubed or to the third power. If you have 4, it's to the fourth power, 5 is fifth power, and so on.
So if the number is bigger, it's the power.
It's still the same thing, but we don't say to the second power. That's just because. Okay, so what I want you guys to do right now is I want you to look at 1A and B. 1A and B. What you're doing for these two problems is you're doing division of prime. Okay? Just like we did right here. Just like we did last week. Okay? Make sure you have a prime number on the outside, and you go all the way until you reach a prime number on the bottom. All right? And then you're going to take any repeat numbers. Okay? You're going to combine them like we did right here. We did right here. Okay? For 16, we had 1, 2, 3, 4 2's. So we put 2 and put the number 4 up top. Okay? It's a small little 4. Okay? We combine all of our like numbers using exponents. So if we have 2 3's, you're going to put a 2 right here. We have 3 2's, we put a 3 right here. Okay? So for A and B, I want you guys to do division of prime and then write the answer with exponents. Yes?
Can I go get tissue?
Yes. All right, guys. So a couple things to remember when you're doing this is, number one, the base. The base right here is the number that we're looking at. The exponent is how many times we're using that number. Okay? The base is the number we're using. The exponent is the number of times we're using that number. So remember that when you're going through this. I will be giving you some homework over this in just a minute. Okay? But right now I want you guys to look at page number 50. Page number 50 in your books. 50. Making a table. Okay? No, we're not talking about dining room table or coffee table. Okay? Making a table. So we have problem-solving strategies, making a table. Farmer Brown has some sheep and chickens. The total number of heads is 25. The total number of legs is 76. How many sheep does he have? Okay. So, how can I set up a table to answer this question? What steps do I use? So, first I need to make a table using heads, sheep, chicken, and legs as labels. So, I'm going to have heads, sheep, chicken, and legs. And then I'm going to begin with 1 sheep and 24 chickens. Okay, so I have to have 25 heads. So if I have 1 sheep and I have 24 chickens, how many legs do I have? A sheep has how many legs?
52.
4. How many chickens do I have? How many chickens do I have? 24. How many legs do chickens have? 2. So 24 times 2 is? 48. So 4 plus 48 is how many? 52. Okay. So how many legs do I have total? How many does this question say I have? No, it says I have 25 heads. How many legs does it say I have? It says I have 76. Right in the purple box at the top, or the blue box. It says I have 76 legs. So, he obviously has more sheep than just 1. Okay? So, what if I have 2 sheep and 23 chickens? How many legs for chickens do I have? Or sorry, for sheep I have 8 legs. Chickens, how many legs do I have? If I have 23 chickens, how many chicken legs do I have? 46. Okay. I had 24 chickens. I had 48 legs. I have 23 chickens now. I have 46 legs. Okay. So 8 plus 46 is what? 54. Okay. Okay, let's jump this up a little bit. So let's say I have 5 sheep now, meaning I only have 20 chickens. How many sheep legs do I have?
4.
If I have 5 sheep, how many sheep legs do I have? 20. If I have 20 chickens, how many chicken legs do I have? 40. So 20 plus 40 is? 60. Okay. Okay. I need to get to 76. So then they have me go up to 10. 10 sheep now. If I have 10 sheep, how many chickens do I have? If I have 10 sheep, if I have 25 heads, 10 of the heads are sheep. How many are chickens? 15. Okay. If I have 10 sheep, how many sheep legs do I have?
40.
If I have 15 chickens, how many chicken legs do I have?
40.
30.
30.
40 plus 30 is?
70.
Okay. How many legs do I need?
76.
76. Okay. Now, let's look at this for a second. If I went up one sheep and down one chicken, I added 2 legs, right? Okay. Now I'm at 70. How many do I need to add to get to 6? If I add 3,
13.
so I'm going to take 13. How many chickens would I have then?
4.
12.
12.
So how many sheep legs will I have then?
13.
No, I'm not going to have 13 sheep legs. I have 13 sheep. Does every sheep have 1 leg?
No.
Every sheep has how many legs?
4.
4. We are on page number 50 on the example.
52.
It would be 52. Okay. I have 12 chickens. How many chicken legs do I have? 24. 76. Okay. So, in order for him to have 25 heads and 76 legs, he needs to have 13 sheep and 12 chickens. And that's how we do a table to figure out that answer.
That's way too much work.
Oh, you have no idea. You're going to get a lot more.
Did 6th grade last year?
Okay. By studying the problem, tell how many legs 14 sheep and 11 chickens have. So if he has 14 sheep and 11 chickens, how many legs would he have? We went up one sheep and down one chicken. So if he has 13 sheep and 12 chickens, that gives 76 legs. If he goes up one sheep, down one sheep, up one sheep, and down one chicken, he would have 78 legs. Yes.
In this problem, what are they talking about heads? Like, are we talking about...
Every animal has a head. You have a head. Gavin has a head.
But, like, why are they counting the heads? Like,
Because it tells how many heads he
do
has.
you eat them?
No.
Do some people...
It's giving you information for the problem. Because if you didn't know how many heads he had, you won't be able to figure out the problem.
So each... Oh. So
Because by knowing the amount of heads that he has 25 total animals. That's what number of heads is saying. He has 25 total animals. You need to...
do this later on in the year?
You're doing it right now.
Are we doing it... Is this
You're doing it right now. That's what you're doing. Number 1. Emily has some $5 bills, some $10 bills. She has 15 bills, and she has $120. How many $5 bills does she have? Okay. So, Emily has 15 bills. So we're going to say bills, 5s, 10s, and then we're going to have a total. Okay? that total needs to equal $120. Okay? So, she has a total of how many bills? 15. Okay? So, how many 5s does she have? 3. So how many 10s would she have? You're guessing to figure it out. If she has 15 total bills and 3 of them are $5 bills, how many 10s would she have? 12. Okay. 5 times 3 is 15. 10 times 12 is 120. So she has $135 then. Is that what we want? No. Okay. So let's say she has 4 5s. That would give her 11 10s. So 4 times 5 is 20. 10 times 11 is 110. 20 times 110 is 130. Sorry, not 20 times, 20 plus. Okay? Let's see here. Now, what we want to do here is think for a second. Okay? If I have an odd number of 5s, I'm going to end in a 5, aren't I?
Yes.
Okay. Do I want to end in a 5?
No.
No, I do not. So I want to keep in even numbers because the total number amount of money she has is 120. 120 does not end in a 5, does it?
Yeah.
So I can count out all odd numbers because anything times an odd number for a 5 is going to end in a 5. Okay? Anything that ends in an even or has an even number times 5 is going to end in a 0. Okay, this is where we're going to have to think a little bit. Now, so if I go ahead and do a 5 right here, I'm going to have something that ends in a 5. I don't want that. So what number should I use right here? 6. So if I have 6 5s and I have 15 total bills, what's my number right here going to be for 10s? 9. 5 times 6 is 30. 9 times 10 is going to be 90. 30 plus 90 is going to be 120. Okay? Oh, look. We figured it out. Okay? So she has 6 $5 bills and 9 $10 bills. And she has 15 total bills and they equal $120. So that's how we do tables. Okay? I don't want to hear another word from you. Okay, let's look at number 2. Caleb sold some boxes of candy. Some he sold for $2, some he sold for $3. He sold a total of 35 boxes and received $92. How many boxes did he sell for $2? Okay. So, what's this problem tell us? What's the information that we need to know? It tells us that he sold candy, right? What else does it tell us, Tony? He sold boxes of candy. What else did he sell? Or what else information do we need? Gavin? He sold some for $2. What else did he sell? Some for $3. What else does it tell us? He sold 35 boxes. What else does it tell us? Tony? He made $92, okay? So using this information, we're going to figure out how many $2 boxes he sold. Okay? So he sold 35 boxes total. So we're going to do boxes. we're going to do $2. We're going to do $3. And we're going to do total. And we need $92. Right? Okay? And he sold 35 boxes total, right? Okay. So, someone give me a number 1 to 35. What? 15. Okay. So if he sold 15 boxes at $2 each, how many boxes at $3 did he sell if he sold 35 boxes?
I don't know.
35 minus 15 is going to be 20. Okay? So, let's look at the total. 15 times 2 is going to be 30. 20 times 3 is going to be 60. Okay. 30 plus 60 is going to be 90. We're close. Okay. So, how do we need to adjust this, do you think? Tony? Okay, think about this. If we sell more $2 boxes, is it going to raise this amount or lower this amount? It's going to lower it, right? Because the more $3 boxes we sell, the higher this is going to be, right? So, if we sold 15 boxes up here, what do we want this number to be? Let's do a 14. Making this number into a 21, right? Okay, so 2 times 14 is going to be 28. 3 times 21 is going to be 63, right? Right? Okay. So 8 plus 3 is going to be 11. Carry the 1. 1 plus 2 is 3. Plus 6 is 91. Close. Which means that we have to make this into a 13. That's a 22. That gives us $92. Because 2 times 13 is 26. 3 times 22 is 66. 6 times 6, or 6 plus 6 is 12. Carry the 1. 1, 3, 9, 92. And we get $92 and $92. Okay? Homework for tonight. Never mind, did not assign a homework for tonight. Okay? You guys got lucky. But I do want you guys to practice doing your division of prime and writing with exponents. Okay? You guys can look at page 49 to do more of those. This will be down in just a second for language. I'm going to cut the stream right now.